Dear student, today we are going to learn about the type of hybridization geometry in tetrahedral complexes. In the last video, I have told you about the geometry and type of hybridization of octahedral complexes. In that video, we have seen about the octahedral complexes and their examples. Now today we are going to discuss about the tetrahedral complexes. In this we shall take first example, that is NiCl by 4 dinegative. Now in this, first you have to calculate the oxidation state of nickel having atomic number 28. Now first you have to pick out the oxidation state of the nickel. How will you calculate? By the oxidation number method. In this you have to pick out the oxidation state of nickel plus chlorine carry a 1 minus charge, that's why we can write -1. There are 4 chlorine are there, into 4, that is equal to net charge is -2, that is we can write here -2. Now solve this bracket, Ni plus, that is -1 into 4, that is equal to -4, that is equal to -2, that's why Ni is equal to +2. Now the oxidation state of nickel here +2. So in this way we can calculate the oxidation state of a given complex. Now we can write here oxidation state, that is OS, is equal to +2. Now the second thing which you have to do, we have to write the valence shell electronic configuration of Ni dipositive by removing the electron. Now how will you write? That is the first step. In second one, you have to write the valence shell electronic configuration of Ni dipositive. Ni dipositive means Ni losing their 2 electrons from their outermost shell. For this we shall write here 3D D, which have 5 subshell, 1 2 3 4 5. Then there is a 4s orbital having only one shell, and then we have 4p which have 3 subshell. Now fill the electron. Its electronic configuration, if you write here, then you can write nickel having 28 with respect to argon having atomic number 18. So 18 electrons are distributed in argon, 1s2, 2s2, 2p6, 3s2, 3p6. These are the 18 electrons. Now the remaining electron, that is if you add 2 electrons, then it will be a 4s2. Remaining 2 electron will be going to the 4s level, that's why 4s2, 18 into 2, that is 20. Now remaining 8 electron will be enter in a 3D level like this. So we shall try to fill this electron. Now nickel have a +2 oxidation state, it means they are losing 2 electrons from their outermost shell, that's why we shall remove 2 electrons from 4s level, that's why this orbit will be, or this shell will be remain empty. Now this 8 electron will be filled as first, second, third, fourth, fifth. Now the remaining electron will be start pairing, that is a 6, 7, and this one is the 8. Now we have to provide the vacant orbital for the bonding with the ligand. So there are 4 number of ligand, that's why we require the 4 vacant orbitals. So 1 electron, 1 shell from 4s and 3 shell from 4p. Okay, that's why 4 vacant orbital, first, second, third and fourth are formed. So here we can write 1s and 3p. That's why type of hybridization will become sp3. Okay, so these are the electronic configuration. Now we can write the electronic configuration after complex formation. Then 2 electron from first Cl will be enter here, like this. So these are the electron configuration or a configuration after the complex formation. Now the geometry for this complex is sp3. What is the geometry? That is a sp3 type of hybridization. Now its magnetic property. Here there are two unpaired electron are present. There are two unpaired electron are there. That's why it is paramagnetic in nature. This complex is a paramagnetic in nature, and its geometry is a tetrahedral geometry. Here geometry is tetrahedral, and type of hybridization is sp3. So we can draw the geometry here. Nickel in the center. This one is the first chlorine. Here this one is the second chlorine. This one is the third one, and here is the fourth chlorine are there. So it will give the formation of a tetrahedral geometry like this. Okay, so these are the first example. To solve the example of NiCN/4 dinegative. Now since you know that nickel having atomic number 28, its configuration will be 4s2 3d8 with respect to argon. Now nickel in a +2 oxidation state, so we can write here Ni positive. Ni positive means nickel losing their 2 electron for the formation of such a complex. That's why we can remove 2 electron from here. Now we can write the valence shell electronic configuration of nickel. That is 3d 4s 4p. Now here 2 electron are already removed from 4s level. That's why this our shell will be empty, and there are 8 electron in 3d level. That's why we can distribute the electron 1 2 3 4 5 6 7 and 8. Since in NiCN/4 dinegative is a low spin complex, that's why it utilizes the inner orbital, that is a n-1d orbital or a 3d orbital. So this electron will be shifted from this level, then its configuration now or a valence electronic configuration will display like this. First pair, second pair, third one, and this electron will shift in fourth level. That's why it will also paired. This will be empty, and this orbital will also be empty. Now there are 4 ligand are there, that is 4 cyanide are there. That's why we need 4 empty orbital. So one orbital or shell from 3D, one from 4s, and two from 4p. First, second, third, and fourth. So 1d, 1s, and 2p. That's why type of hybridization here DSP2 type. Okay, and DSP2 type of hybridization gives square planar geometry. So we can write the geometry here, Ni in the center, and there are four cyanide which are present at the four corner like this. So in this way we can write the electronic geometry and type of hybridization. Now the magnetic property. Since in this there is no unpaired electron are there, that's why this complex is